Guys, we will see how to configure BGP. It's a basic configuration from scratch. So I'm going to build topology on EVNG. I have certain iOS here. So I'll take 7206 VXR router. So the number of router I'll take 3 and get slot 1, slot 2. I'll take those 2 slot. It's fine. Alright guys, let me connect. So connection has been completed. That I'm just going to start a node, and yes, it started. So just double click on the router, your terminal will be open. Yeah, I have a continuous ping over here. This is I'm just going through a startup configuration. Skip. Yeah, so basically I'm here. Let me open this one also. VXR1, VXR2, and this is the third one, VXR3. So now we have all 3 router open, and like we can start configuring. So let me give the host name. This is R1 fine CISCO Cisco. Cisco. Skip this. Similarly, I have to make it happen here also. Yes, yes. This is R3 Cisco. Admin Cisco. Let me skip this step. Fine. Alright. So guys, like as you can see, this is Cisco 7200 street router. Yeah. So let's go to enable mode. DL3 interface. The connected interface is FS0/0. Let's go in config T mode, global config mode. Let's give IP. We can give IP 0.0.1.2.5.2.5. Sorry. Save configuration. Let's do a self ping here just to verify your interface are sorry. So interface f0/0 no shift IP address 12.0.0.2 because we have given .1 there, and we have a subnet mask of class 30, so we will have only 2 usable IP here, so that's why we have to give 2. Ping 12.0.0.2 self IP is pinging. Let's see the neighbor IP. Yeah, it's pinging, it's reachable. So first we will make a point-to-point reachable, then we will configure the IGP, then we will configure BGP. Yeah. I'm sorry, I think we have to configure one more IP here. Interface FA. This interface we have to configure. FA 1/0. Sharp. 15.0.0.1. Fine. Route/0. Sorry. So again we will have /30 subnet 255.255.2. We can give a big subnet also, guys, but basically in the ISPs or in the big network, so we always take /30 IP. 252. So it's a good practice also. Let me check the self IP. Self is reachable, neighbor IP is reachable or not? So it's reachable, fine. So we have established a point-to-point connectivity so far. So now the next thing is that now we have to configure BGP between these two and here also. So in order to configure the BGP, because this is the same AS number, because these 3 routers are in same AS number, so first we would need to configure the IGPs among all the routers. Once we will have a reachability from this router 1 to router 3, then we will configure BGP, iBGP over here. So as IGP, I will configure OSPF as the routing protocol. Router one the pulse ID. Sorry. Network 12.0.0.0. Two wildcard mask 0.0.0.3 area 0. So sorry. See, so immediately OSPF has come up. Actually, I was running the XROS command. So here's the this full BDR. See, the thing is like we have configured OSPF as a broadcast mode because we haven't. This is a Ethernet interface. It is by default broadcast mode. So if you want to make it like a point to point, then we would need to configure the point to point interface. Otherwise, it will show DR and BDR mode. So let's make some changes here. Interface. OSPF network point to point. So once you will add this command here and show IP OSPF neighbor, see now it is full. So it is not showing as a DR BDR here, so now it is going to be like a point to point OSPF. So here you will see OSPF LSAs also. See, this is the router LSAs here. Okay guys, so from here, since we have to give this configuration, fine. Now it came up. Now it came up. So similarly we have to make it point-to-point interface. It's not a matter, but it's better. You have to keep it, you should keep it point-to-point interface. So the thing is, like, it is negotiable. Like, once you will configure point-to-point in any of the router, in any of the interface, like, it will become a point-to-point. You don't have to mention point on both sides. See, now it came up. Okay, let's configure BGP from here. Let's take an IS number 100 here. The network IP is 12.0.0. Remote is, because it will be an iBGP, so remote is so there would be one more neighbor here for the router 3. So all BGP has been configured. Let's see BGP status here. So both BGP has come up here. So let's see how many prefix we are receiving. So guys, basically currently we are not receiving any prefixes over here. So there is a reason we have to redistribute the connected route. The first thing is there is no prefixes over here. So what we have to do, redistribution over here. Then you will be able to see the prefixes. So either you can do redistribute connect because all the routes are connected over here, or you can do manual configuration also, like network IPs. So you have either ways. So it's easy to do redistribute connect. So once you will configure by network command, and so network command is always preferred over the redistribute command. So So in the production network, people usually configure. Sorry. So show iBGP now. Show iBGP. Now we can see some routes here. This is 12 route. This is showing a next hop. This is the best path. This is the best path. It is showing default. Next hop is showing default. Default means it is self originated, and the weight is also showing 32768. It is locally originated. So and the second route is 13, which is the interface between this one, and it is coming from 12.0.0.2. So this is how it is. Like once you will see, this is the local preference weight S path. S path will not show because it is the iBGP, unless traffic will go outside from the S autonomous system, it will not show. So once the traffic will be going outside to autonomous system, it will be showing, it will be carrying a S path. So this is the first thing. So guys, basically this is all connected routes here. So guys, we will do one thing. Let us configure one loopback interface over here. Loopback 0, address 1.1.1.1, 255.255.255.0. See, this is the loopback IP, this is a self originated. Now you see the route table, BGP table. So guys, what we are seeing here, like this is the router one. We have created loopback IP in all three routers. So this router has its own loopback IP, and it is receiving from the router 2 also this loopback IP, but router 3 loopback IP 303 is not showing in the route table, BGP table of router 1. The reason is that, like, BGP has one split horizon rules, so it doesn't exchange, like, when once this router will receive route from the router 1, it will not send router 1's route to the router 3. So there is the reason behind this, like, once there will be a backend connectivity between router 1 and router 3. So if this router will send the router 1 route, I mean, like, if router 2 will receive any route from router 1, and then that route will be further advertised to router 3, okay, and then let's suppose you will have some backdoor link, or there is a connectivity between this router 1 router 3, it will be, then router 3 will send this route back to router 1, right? So by default, that's why by default router, this transit router will not advertise the routes which it has received from router 1 to router 3. This is the by default features of BGP, and this is known as split horizon rules. So like, but in the production environment, like, it is not like this, because some user is sitting over here and some user is sitting over here, and both want to communicate to each other. So you have to exchange the route of router 1 to router 3. So in this case, like, what we can do, we have multiple option. Either we can make it full mesh, or we can configure like Route-reflector. This router can be configured as Route-reflector, or if we have a big network, we can configure configuration also. So here what we will see, we will do a Route-reflector configuration, and we will see whether router 3 is able to receive route from router 1 or not through router 2. So let's configure Route-reflector. Basically, as a name, Route-reflector take a routes from one router and reflect it to a third routers. So that's why its name is Route-reflector. But there are multiple attributes over here for the Route-reflector. I'll tell you. I'll go in details later on. One sec. Let's do a configuration. So this is the current BGP table of router 3. So what happens in Route-reflector? This is the Route-reflector, this router. So what we do, neighbor IP, so the thing is, like, if this is a Route-reflector, so this router can make any of the router as a client, or both also. If they are making both router as a client, Route-reflector client, it is fine. But in case, like, if you forget to configure Route-reflector client toward this router 3, you just configure toward router 1, it will work also there. So there is no any objection, there is no any issue. So let's see. I'll hit enter. So the thing is, once you configure Route-reflector as a client, so, like, your BGP will be refreshed and your BGP will be flat for a moment, and then it will come back up. So it's a outage, so it's not a normal configuration. So let's see the BGP table on the route 3. See, now when I configure this router as a Route-reflector, this router is receiving a route loopback IP which is advertised by router 1. So now it has route. So the thing is, like, when you will see show IP BGP 1.1.1.1, so you will see multiple things because it is received from Route-reflector. So you will see origin, yeah, originator ID, cluster ID. So basically these are the attributes of Route-reflector. These are the attributes of BGP, especially when you have a Route-reflector. So like I told you, like, tomorrow if somebody is going to add one more link between these two routers and they are going to run full mesh BGP in the network, then what will happen, this 1.1. route, this router will further advertise this route to this router 1. So there will be a chance of loop. But since BGP is very smart protocol, it has this attributes. So what will happen, when this 1.1 will be advertised back to router 1 from router 3, so this tag will be added with the BGP routes, like originator ID and cluster ID. So basically originator ID is the ID of the router which from the beginning, the router which has advertised routes from the beginning, like I mean the first time the router which has advertised the routes. So this is the router. So what you have seen here, the ID is 12.0.0.1, right? This IP is configured on this interface. It means like when you configure Route-reflector client between this two router, like on this router, so it become a client of the RR. So whenever it becomes the client of Route-reflector, so it decide like whenever I will have to advertise any IPs, any prefixes to the Route-reflector, I will add my originator ID, so that if the same prefixes will come back to me from anywhere, I will see in the packet that, oh, my router ID is there. So it means it is mine uh, prefixes. So it will not install that prefixes again in their route table, in their BGP table. So loop, this is how the loop can be avoided over here. So this is how this is the main objective of this originator IDs. The cluster IDs, like basically it is representing the route reflector, because what happens in production network, you may have a multiple route reflector. So if you have multiple route reflector, it means like you should have some kind of IDs which defines that which route reflector is this, or any prefixes coming from the RR1. This cluster ID is denoting that, okay, this prefix is coming from that RR, and this RR is the IP, has this IPs 13.0.0.1. So that's all, guys. So actually, like, I'm trying to capture some videos on routing protocols like BGP, OSPF, MPLS, segment routing, EVPN, and SRLG also. So I will gradually add some videos in my YouTube channel. So just look at it and give a comment. I'll try to do my best. And not only networking, like I have experience in cloud and virtualization. Like I have worked on OpenStack Cloud and VMware virtualization also. So I'll try to build a video on that also. Thanks. Thanks a lot.